Now, we want to talk about the part 2 of this video. And in this part 2, we are going to be looking at bearing questions that can be resolved into polar form. Then when you resolve them into polar form, then you what? You use them to what? To solve problem. That means you can solve bearing question without actually drawing the diagram of those particular questions by representing them with the diagram. Now, if you have a diagram or if a quadrant like this now, this is a quadrant, this is east, this is north, this is west, and this is what? South. Now, I've told you in our part 1 video that all bearings start from the north, while all vector clockwise direction, while all vectors is from the what? East anti-clockwise direction. So that means for vector, which is the main important, the angle, here is 0, then you rotate what? Anti-clockwise direction. But bearing rotate what? Clockwise direction. Now, in vector, you consider the what? The anti-clockwise direction most important, but you must what? This one is for bearing. Then this arm is what? Vector rotation. Vector angle what? Rotation there. How it can be measured. Now, having known that now, the next thing to do is that don't forget eastward. Anytime they mention the word eastward, that means east, due east. The angle you consider is 0 because that is the starting point. Now, northwards is what? Is 90 degrees. That means from here to this place 90 according to bearing. So here is 90 degrees according to vector rather. Then the westward is what? 180 degrees. So if you are moving from here to this place now, is 180 degrees westward. Then southwards is 270 degrees. Southward, that means from here, if you move from north to the what? To the south, it's what? 270 you have moved. Now, don't also forget, if you say northeast, northeast is what? Dividing what? The line that divides the east and north equally. If you divide east and north equally, what you are going to have is what? Northeast. And in that case, here will be what? 45. Here will be what? 45 degrees. Similarly, if you have what? If you have what? Northwest. Northwest is what? Is dividing north and what? And west equally. So here will be 45 degrees. Is northwest or west north. Here also 45 degrees. If you say southwest is what? Dividing what? West and south equally. And here will be 45 degrees. Here also what? 45 degrees. So southwest. What about what? The last one, which is for what? The southeast. The southeast is located in this direction between the north and the south and the east, and the east you divide them equally. But you know that all our angle must be measured from the what? From the east in an anti-clockwise direction. So if I rotate this to meet this now, I rotate this what? East to what? To meet up with what? North what? West. Watch. I rotate this one to meet what? The south what? West. Then finally, I rotate what? This to meet up with what? With south what? East. Now, if you check the rotation very, very well, northeast is what? 45 degrees from what? Positive x direction. Look at it now. From here to this place is what? Positive x direction. You rotate anti-clockwise. So northeast will be 45 degrees. Then northwest from here you rotate like this now. From here to here is 90 plus 45. What will be what? 135 now. Look at it. From here to this place is 90. I've even written it there. Add 45 to it to move the angle from here to touch this northwest. It's what? 135. from what? From the positive x-axis. Then the same thing, what? Southwest to the what? This is what? 180 to this point plus 45 will give us what? That is south what? West will be 215. 180 plus 45. 180 plus 45 give us what? Sorry, 225. Then the last one is what? They will now take this one, which is what? From here to this place 90 plus 90 is 180 plus 90 is 270 plus 45 is what? 315. So south is 315 degree. Just add 270 plus what? Plus 45, you get 215 from positive x direction. Now, but sometimes we can have a question in bearing format. So they can say, for example, let me say a body is displaced 30 degree north of what? West. For example, it displaced 30 meter what? In the direction, let me put it, in the direction 30 degree north of west. How do we resolve it in polar form? I've explained this one. I'm coming back to this. How do we resolve it in polar form? What you just need to do is what? Simply what? Just what? Look at it here. North, 30 degree north of west is same thing as what? Can be written as what? West 30 degree what? North. Don't forget that I can remove the off and interchange, bring the west forward. So that will give us this. Now, if you want to draw it, that means you have to start from the west. The angle must start from the west and rotate what? 30 degree towards the north. That is what you call 30 degree. Now, but that is not the main thing there, because this is the bearing movement that we have talked about. That means we have resolved this direction. But I told you all angles should be measured from where? From the positive what? X-axis, anti-clockwise. So you have to rotate like this. Look at me. So what is this angle? This angle will be what? 150 degree. 150 degree. If that angle is 150 degree, therefore, this, what the magnitude is? 30 meter. So in polar form now, our angle that what? Our magnitude is 30 meter. Our what? Direction is what? 150 degree, which is measured from the what? Positive x axis in an anti-clockwise direction. So if I want to resolve it now, I will now resolve this one as what? 30 cos 150 degree, 30 sine 150 degree. I've ended up resolving this particular vector. Now, if we want to resolve probably another one, let's say a body displaced what? A body displaced what? Let's say 30 meter on a bearing of 280 degree, for example. How do we resolve it in polar form that will now make us what? Resolve the what? Into x component and y component. How do we do that? So what you're going to do is simply what? Obey bearing first. What is bearing saying? Bearing say all the angle, bearing angle must be measured from the north in a clockwise what direction? I've explained that before. So if you want to now resolve this one, what do you do? Draw your bearing. This is north, east, south, west. You will start from the north. From here to here is 90, 180, which is smaller than 280, 270 is a little bit smaller than 280. We take it a little upward. No, you are not using compass. So this is where your what? Your 280 will be. So this is 280. Now don't forget, if that is 280 now, 280 degree, that means your direct magnitude will now be 30 meter here. Now if here is 280 according to bearing, what will be this balance point? Because I need it. What will be the balance point? Everything from beginning to this place is what? 360. If you move from north to north, it's 360. But if we want to now balance it, what will be this place? If you remove 280 from 360, what do you have? You are going to have what? 80 degree. 80 degree, the balance, this balance angle here. If here is 80 class, what do you have? It's just for you to what? Move here. Can you see it? Anti-clockwise. You want to get the vector angle now. So for us to get the vector angle, you have to move what from the east anti-clockwise. So move like this. So what is that angle not going to be? This is 90 and this is 80. That is 170 degree. That's what it means. That's 170. Because this is 90 from here, from the east to the north, 90 plus the 80 to get to where the displacement is. So that will then be 170. So we can write it as 30 meter, 170 degree from where? From the positive x-axis. So if you want to resolve it now into two what dimension, x component and y what component. What do we do? It will now be what? This one now be what? 30 cos what? 170 degree and 30 sine what? 70 degree. So you have resolved this particular what? 30 meter 170 degree into polar form. So that means into x and y component. And don't forget that what? That you have first of all convert the bearing to what? The bearing angle which is 280 from the north, convert it to what? Vector angle which is 170 from the east anti-clockwise. Then before you now which is what? This is polar what? Form. Then before you now what? Resolve it into x and y components. I believe this is very clear. Now if I ask you, for instance, if I ask you that something move what 20 Newton what eastward should be what class? 0. So if 20 meter eastward is 0, so that means I would have 20 Newton what 0 according to what I have said. Look at the board. This is 0. So it will be what? 0. So in that case now, if it is 0 now, then this one will be what? 20 Newton 0, the force. If they give us like this, eastward. If they give me what? Then you can resolve 20 cos 0 on the x-axis, 20 sine 0 on the y-axis. If they give me what? 20 Newton northwest, for example. 20 Newton northwest, this is the force, the magnitude, and this is the bearing direction. I can convert this one to that word vector. What is northwest from the east anti-clockwise? Is what? 35. So this one have what? 20 Newton 135, which I can resolve into what? 20 cos what? 135 on the x component and 20 sine what? 135 degree. So and so forth and so on. You can keep doing that continuously. If you want to resolve what? For example, south. They said what? The boy displays what? Or 20 meters south. You should know what to do. 20 meters south is 270. So 20 cos 270 and 20 sine 270. You just resolve it like that. And before you know it, you get better. And don't forget that if I have what? For example, I say what? A man displaced what? 100 meter on 100 meter in the what? Direction what? Not what? Okay, let's say south what? West. Southwest. Now how do we resolve this one in polar form? Now southwest from the east anti-clockwise, the vector angle from the east anti-clockwise is what? I told you is what? 225. How do I get? From here to here is 45. If you divide the angle into 3 copper, here will be 45, here will be 45. So 45 added to 180, that will give us 225. So 225 will be 100 meter, which is the magnitude, then 225, which is the direction. So if you want to now resolve it, you can resolve what x component will now be what? What will be x component? Now be what? 100 cos 225 degree. Then the y component will now be 100 what? Sine 225 degree. We have successfully resolved the angle. You understand me now? That is how to go about it. It's not difficult, it's not hard. Now let us take an example. And when I take an example, I'll take two examples. Then maybe in the next class, we will not have enough questions. That class will not be used for analysis. We'll just take both vector question and bearing question. That is part 3. So before we now look at part 4. Part 4 will now be a general analysis of other solutions that you can derive from there. So if we take a simple question now, let's take a simple question. Let's take a quick simple question. I have a question here that very interesting I want us to look at. Let's say a boy, let me check my marker. Sorry for that. A boy starts what? From his room. And walked 20 meters south, and then turns and walked what? 30 meters directly what? North. Now see what? Walk. Okay, I missed one. Turns and walk 50 meters. Sorry. 50 meters in the direction. In the what? Direction. 30 degrees north of west. And finally, walk what? 30 meters directly what? North. Full stop. Now say, find the what? Find the magnitude. Find the magnitude and direction of the what? The displacement from his room. Now, this is a vital question I want us to look at. And quickly, I want you to listen. This is a vital question. I want you to apply everything you have learned so far inside what? This particular question. I want you to listen. You will enjoy the question. Now, this one said a boy starts from his room. Starts from his room. The boy starts from his room and walk 20 meters what? South. Let me put it there. 20 meters south. Now, how do we interpret the 20 meters south? South is what? If you check the last video, is what? 270. Look at it here. This is south. This is south. And if you move from here to this place, 270. So 270, so 20 meters, 270 degree. So if you want to resolve into x component and y component now, how do you do that? X component and y component of that. That would be what? 20 cos what? 270 degree and 20 sine what? 270 degree. Now the next thing is what? And then turns and walk 50 meters in the direction 30 degree north of west, which is same as north what? North of west. That means you remove this up and change this what? West forward. So that be what? West 30 degree what? North. How do we draw that one? North 30, west 30 degree north is what? Like this. West. This is what? 30 now. This is west 30 degree north. That means you start from west and rotate 30 degree going towards the north. So what will be this angle now? This angle, which is the main angle, the vector angle, is vector angle. It's going to be what? 150 degree. Because from here to this place is 180. If you remove 30 from it, what do you have? 150. So here will now be what? 50 meter, 150 degree. So this will now be what? 50 cos what? 150 degree. Then 50 sine what? 150 degree. Then the last part, which is what? In the what? And that's it. And finally, what? 30 meter directly north. So 30 meter northward, north. North is 90. I told you, according to vector, from here to you start from the east and rotate towards the north. This is 90 now to the north. So this one is what? 30 meter interpretation and 90 degree. So this one is like interpretation of into polar form. Then this one is the resolution. So this one is resolution. So we have resolved what? The three of them. And this one will be what? 30 cos what? 90 and 30 sine what? 90 degree. So we have resolved the three of them. Then you now find their resultant. What is their resultant? What? Along the x and along the y. So what you are going to do for me, let's press our calculator and see what we are going to have. We are going to have 20 cos what? Cos 270 plus what? 50 cos what? Cos 150 plus what? 30 cos what? 90. That will give us what? Minus 43 point what? 3 meter. Then what about the other side? We have 20 cos what? Sine what? Sorry. Sine 270 plus what? 50 sine what? 150 plus what? 30 sine what? 90. You can press your calculator alongside we are working with. This is 35 meter. Now, if you have that now, 35 meter, this is what? Our resultant along the x and along the y. Now, you can actually do all the things I have done in part 1. This one is what? The distance in vector form, the resultant in vector form, that was minus 43.3i plus what? 35j, all in what? In meter. All in meter. This is our resultant. So in this case now, don't forget that if you resolve it like this, your resultant for this is the vector form. In magnitude now, what will be in magnitude? The resultant first in magnitude. Yes. You just need to use your formula. What is the formula? Square root of what? Dx squared plus what? Dy squared. That's our formula to use. Because this is our ds, this dy, because we are talking about displacement, which will now give us what? Minus 43.3 all square plus what? 35 all square. Then square root of everything. What do we have? If you press your calculator, you are going to have it as what? Press your calculator there. What you are going to have is what? 43.3 minus 14 all square plus 35 square. Then square root of everything. You are going to have 55.676 meter. You can press your calculator to confirm it. So that is what we are going to have as our what? Which are probably 55 rather, point what? 68 meter. Highlight. Now, what about the direction? Now, the direction now, don't forget. Look at the board. Now, we have negative x and positive y. So, which quadrant do you think it will fall? It will fall in the what? The second quadrant. Look at it now. S is negative, y is positive now. So, if s is negative and y positive, this is the direction now. And that is the direction. So, if that is the direction, we are going to have an inverse of what? Is now in second quadrant between west and what? And north now. So, and it's lying, it must be lying across along the horizontal line. The reference line must be what? Along the horizontal for the direction. Now, what I would do now is what? Is to say 35 over what? 43.3. So, what do you have there? I'm going to have 34 shift, then 35 divide by what? 43.3. Remove the minus sign. That will give us what? 38 point what? 94 or 95. So this is what? 38.95. So if you now what get this one, now what will be this angle? Just to remove it from 180. Remove that answer from 180. You are going to have what? The direction will now be what? 141.05. That means from the positive x-axis now. From where? Positive x-axis. But if you are using this 30, what do you call 38.94 something, which approximately 38.95 angle, the direction, if you want to use it, what do you do, class? You don't forget that we can get this angle here. Can get that angle. Have you forgotten that from here to here is 90? Yes, now. So if that is 90, that 90 minus what? 38.95. What do we have? We have 51 point what? Let's say 51.05. So if I want to write it now, I will write it as what? West 38 point what? 95 degree what? North, or 38.95 north of west. That is first answer first. This is the first answer. The second answer. We can still write it as what? If this one angle is resting on the north, so we can write north 51.05 degree what? You can see it. Then resting on the north, going to the west. Or we write it as what? 51.05. So it's point here. Degree what? West of north. West of north. Somebody can say, okay, we want to calculate what? The angle from the what? You can still say what? It is what? 38.95 above the what? The positive x-axis or the negative x-axis. It's above the x-axis. Lastly, you can say that what? You can calculate this side. This place is alternate to this place, and this place is alternate to this place. So here it can be 51 point. That means the worst case scenario. So you can call it what? This one can be what? It can be, that means east, south. That means the worst case scenario. But probably me personally, I'm not okay with that. But in case in an examination condition, you now see all this answer. Probably you now see this. Yes, we have seen question like that. You have 38.95 because this is alternate to this one, and it's resting on what? East. So it now be east, south. That is 38.95 degrees south. Or you write it as what? Using this one, you can write it as what? South what? 51.0 degree what? East. You can see introduce off. That you can do by yourself. So all these are possible answers of direction. Magnitude is never a problem, but the direction. And you see the way we resolve, instead of drawing this diagram in vector and bearing, we have resolved it into what? The bearing statement interpreted into polar form. From polar form, we resolve into x and y. From x and y, we get our x coordinate, sum of x, resolution along what? The resultant displacement. This resultant what? Displacement along what? X and y. Then from there we find magnitude, we find what? Direction. You know, this is direction and this is the magnitude. So all this you can get, and if you want to leave the resultant in vector form, this is the answer in vector form. So all this are very clear. I believe in the next class, we are going to spend time in solving more questions. Just solve question. It's going to be a lengthy video. Just get ready. We solve more questions to apply all these things, both the vector question, vector resolution question, and part 1 and part 2. We'll be applying part 3 so that we can have a confident understanding about what? About this particular analysis. Thank you very much. God bless you for watching. Have a wonderful day. Please enjoy your work, more of this video by subscribing. Subscribe to the channel and support us. That is a way of supporting us to show that you will actually enjoying our video to do more. So thank you very much for subscribing and for commenting and for liking our video. For liking the video, what we appreciate you a lot. Thank you very much. God bless you. Thank you. See you in my next video, and make sure you stay safe. Thank you.